Building your own airplane is a fun, exciting, and rewarding challenge. Once you've completed your dream project and have the airworthiness certificate in hand, comes the next big challenge: flight testing. The EAA has recently published this flight test manual. It is full of great suggestions to help you safely and efficiently test your new aircraft. Flight Test 10 describes one technique to determine your takeoff performance. In this video, we demonstrate an alternative method that does not require a spotter on the ground and which will produce more accurate and repeatable results. To use the Flight Data Viewer's Takeoff Performance Analysis tool, you must have an MGL EFIS with a GPS receiver and an outside air temperature probe. Acceptable devices include the classic Enigma and the newer iEFIS systems like the Explorer or Challenger. First, flight data recording must be set to manual, and data recording must be started before turning onto the runway. This is necessary so that the entire takeoff is recorded. If you use automatic flight data recording, you will miss most of the ground roll. The third requirement is that you must pause on the runway for about 2 to 3 seconds before you begin the ground roll. The analysis procedure looks for a period where the ground speed is 0 followed by takeoff acceleration. Here is how that looks in practice. Before or after the aircraft run-up, manually start flight data recording on your EFIS. After turning onto the runway and lining up with the center line, come to a complete stop and pause for approximately 2 to 3 seconds. Then begin your takeoff as normal. Pitch and trim to the best angle or rate of climb. Once you've climbed to over 50 feet, you can pitch down to increase speed if necessary. At this point, enough data has been recorded to calculate takeoff performance. Enjoy the rest of the flight. Here we see the test flight already loaded into the Flight Data Viewer. See the link in the comments below to view an introductory video showing how to extract the flight from your MGL device. First, we need to select the range of data that includes our flight's takeoff. The easiest and best way to select the start of the range is to view the airspeed and ground speed graph. Use the slider at the bottom of the graph to magnify the x-axis. Move the graph to the left to view the start of the flight. Click on the graph where the ground speed is 0. This is where you remain stationary on the runway prior to takeoff. Note the ground speed in the table below. It must be 0 for the analysis to run correctly. Now select the end of the range. Here you are looking for a point in the takeoff where you have climbed to at least 50 feet. The best way to do that is to view the altitude graph. Hold down the Shift key and click on the graph. The next step is optional but recommended. Name and save the range so that we can recall it quickly in the future. Right-click your mouse on the table and select Define Range. Name this range First Takeoff and select Short Field Takeoff as the range type. Click OK to save the range. Now click on any point in any graph. Notice how the range goes away. You can easily reselect it by clicking on the table and selecting the range by name. Now run the analysis. Using the menu, select Analyze, Takeoff Performance, and then calculate and save takeoff performance for current range. The result of the analysis is shown here. The ground roll was 1,228 feet. The distance to clear a 50-foot obstacle was 1,537 feet. In the tables, the following values are shown: runway elevation, outside air temperature, the altimeter setting, the density altitude, the indicated and true air speeds at takeoff, and the ground speed at takeoff. The third column of the table contains optional input fields. The takeoff weight for this flight was approximately 890 pounds. 15 degrees of flaps were used. Uncheck the COM winds box and enter 280 degrees at 2 miles per hour. The runway heading is calculated using the GPS ground track at takeoff. Correct if necessary. This was a short field takeoff from a paved runway. Add any notes about this test flight. We now have calculated the takeoff performance data for this test flight. Save it so that we can compare it to other test flights. Click the Save Performance Data for Future Analysis Comparison button. To view all the data from previous takeoff performance test flights, using the menu, select Analyze, Takeoff Performance, and then View Analyze Takeoff Performance Data. Here we see a data grid with each of the previous test flights. By default, the data is sorted with the most recent flight first. But that order can be reversed by clicking the column header. You can sort on any column. Since we are going to look at the performance for short field takeoffs, we'll sort using the takeoff type column. Select each of the short field takeoffs. Notice that as we select each one, the graphic above is updated to show the average of the ground roll distances and the distances to clear a 50-foot obstacle. We can print this data. For this demonstration, we'll use the Print Preview function. The printout will show all the details of each test flight. The average, minimum, maximum, and standard deviation statistics are shown below. Data can also be exported to Microsoft Excel as demonstrated here. After you have gathered data from several takeoffs, you'll have a very accurate picture of your airplane's takeoff performance. Add that data to your pilot's operating handbook. Have fun building, testing, and flying.